I'm Anil Kumar, and now let us explore the properties of roots of quadratic equations. Find the equation whose roots are each 5 more than the roots of given equation, right? Now, in the given equation, we know A is equals to 2, B is equals to minus 17, and C equals to 2 when we compare it with standard equation of the form of ax square plus bx plus c equals to 0, correct? Now, you can also write a quadratic equation as an equation with sum of roots and product of roots, right? I hope you remember that. It could be written as x square minus sum of roots, which is, let us say, x1 and x2 are the roots, times x plus product of roots, x1 times x2 equals to 0, right? Now, if you compare these two, then what do you find? You find that the sum of roots, that is x1 plus x2, if these are the roots for the given equation, should be equals to minus b by a, so which will be minus of minus 17 over 2, right? So that is 17 over 2. And the product x1 times x2 is equal to this number, which is c divided by a, right? So when you divide by a, this is what you can compare with, right? C divided by a, c is 2, a is 2, so product in this case is 1. Now the question is, find equation whose roots are each 5 more than the roots of given equation. So the new equation should have roots as what? The roots are x1 plus 5, that is 5 more, right? The first root. The second should be x2 plus 5. So these are the roots of the new equation, right? Let us now find sum and product of these roots. The sum of this root will be x1 plus 5 plus x2 plus 5, and that is equal to x1 plus x2 plus 10, and we know x1 plus x2 is how much? 17 over 2. So that is 17 over 2 plus 10. So that is their sum, which we can always write as 17 plus 20 over 2, or you can say 37 over 2. So that is the sum of these roots. Okay, let me push this page a bit forward. Okay, now let's find the product. So product will be x1 plus, okay, let's do it here. Let's do it on this side. So we'll find the product. So product will be x1 plus 5 times x2 plus 5, right? That is equals to x1 x2 plus 5x1 plus 5x2 plus 25, and that gives us x1 x2 plus 5 is common, x1 plus x2 plus 25. Now x1 x2 is known to us, which is product of these two roots as 1. So this is 1 plus 5 times x1 plus x2 is this fraction 17 over 2 plus 25, right? So that makes things very difficult for us. So what we get here is 25 plus 1 is 26 plus 17 times 5 divided by 2. 7 times 5 is 35, 5, 3. 7 times 1, 5 times 1 plus 3, 85 divided by 2, right? So that gives us a product. Let's add it. So it is 6 times 2 times 52 plus 85 over 2, right? So 5 plus 2, 7, 8 plus 5, 13. So you get 137 over 2. Well, my calculations could be wrong. Just check them. But I hope you understand the method, right? So now we know the product and we also know the sum, right? So we have sum here, sum of roots, and that is the product, right? So that gives us kind of equation. So we can write down the equation, which should be x square minus sum of roots, which is 37 over 2x, don't forget that, plus product, which is 137 over 2 should be equal to 0. Let's multiply by 2. So we can write 2x square minus 37x plus 137 equals to 0. So that is the answer for the given question. I hope that helps. So the strategy is define your variables x1, x2 as the roots, find the sum and product, and then find the new roots, which is as per the condition 5 more, and then find sum and product of the new roots. Use the values from the previous roots to find the answer. So the beauty is that you don't really have to find the roots of the first equation or the second equation, but you get your solution. And that's how the properties of roots of quadratic equations work. I hope you appreciate it. Thank you and all the best.